Welcome to my channel. In this video, you're going to learn about the domain and range of a function. So what is domain and range? Domain is the set of all possible values of x, or also known as input or independent variable. Range is the set of possible y values or output or dependent variable. So I have here set of ordered pairs, and we know that these ordered pairs each one has x coordinate and y coordinate. So the x coordinates, these are what we call the domain, and the y coordinates are what we call range. Now, so the domain now we have here, we can list it in increasing order. We have 1, 3, 4, and 6. Okay, so it's a set. And then the range, or all y values, we have -1, 3, 5, and 7. That's arranged in increasing order. Now, let's learn about function notation. So we have here f of x. Again, read as f of x, not f times x. So f of x is actually y. So we can change that. Let's say we have y is equal to x squared plus 3. We can change that y to f of x. So we have now f of x is equal to x squared plus 3. So function notation is just the shortest way of saying that we are talking about function. If you have seen this f of x, or you can use letter like g of x, h of x, like that. Now, in f of x is equal to x squared plus 3, that letter f there, or f of x, that is name of the function. So if you have the other name, you can have that g of x, or you can have h of x. Okay, then that x there is what we call the input or domain. So if you're going to assign values of x, so this is, you're going to write it here. And then all of this, x squared plus 3, so this one. Okay, all of this, this is what we call a function rule. It means it tells you what to do. And then, if you're going to perform that, the result is what we call the output or the range. Again, this is the function rule. And then, if you're going to perform this, let's say the function rule says that square the x and add 3. And then if once you perform that, the result is what we call the output or the range. Now, let's have the given. F of x is equal to x squared plus 3. Then we're going to find f of -2, f of -1, f of 0, f of 1, f of 2. It means the value of x that we're going to substitute is -2, -1, 0, 1, and 2. So let's do the f of -2. So f of -2 is equal to, just substitute x to -2, then square it and add 3. So that is 4 plus 3 is equal to 7. F of -1, so f of -1 is equal to -1 squared plus 3, and that is 4. F of 0, so change the x to 0, so that is now equal to 3. And f of 1, so that is 1 squared plus 3, that is equal to 1 plus 3, that is 4. And the last one, f of 2, is equal to 2 squared plus 3, that is 4 plus 3 is equal to 7. Now again, -2, -1, 0, 1, 2, these are now the x values that we input, and this is what we called also the domain. But this is not the complete set of domain because we can assign any values of x here, right? And then every time we assign values of x, we have values of y. So here, 7, 4, 3, 4, 7 are values of y, but this is not the complete set of values of y, or what we call the range. So how are we going to determine the complete set of domain and the complete set of range? The better way to identify is to draw the graph. So now we have the following ordered pairs: negative 2, 7. So here, negative 2, 7, negative 1, 4, 0, 3, 1, 4, 2, 7. Let's start with this. So what are we going to do is graph or plot the point. Now let's plot the points on Cartesian plane. So we have here negative 2, 7, negative 1, 4. It's here. We have 0, 3, 1, 4. 1 is x, 4 is y, 2 is x, and 7 y. Okay, then we are going to connect the points. That's the graph of this function. Now, if you look at now the x-axis here, look at this one. We can assign any values of x. Farther from 0 to the left, and from 0 to the right, also we can assign any values. Let's say we're going to assign x as 6. You notice, if this is 6, it means that the graph will stretch going to the right. And also, if we're going to assign values less than the negative 5, it means that the graph here, the other part of this graph, will stretch also going to the left. Which means that the domain of this kind of function is the set of all real numbers. Okay, so any numbers here on the x-axis. And we can write that in interval notation since it continues to the left or to the right, which means that in interval notation, we can just write from negative infinity up to positive infinity. Continuous. So when you are going to use the word or the infinity, it means that you're going to use parentheses. Now, what about the range? If you look at the range here, this is the lowest point here, and then the graph going up, which means the lowest value of y is 3, positive 3. And then the rest going to positive infinity because of this arrowhead. So therefore, the range is this one. Read as, range is the set of all y such that y is greater than or equal to 3. Okay? So there, since greater than or equal to 3, so that means all the values of y going up. And then, in interval notation, we can write it this way. Since negative 3 is included, which means that we're going to use bracket, and then comma, up to positive infinity. And this is parentheses. Okay, so note that if the given function is in one variable and the exponent of x is 2, that is called quadratic function. The domain is always set of real numbers. So there, you don't have problem anymore in finding the domain if the function is quadratic. It means there is one variable and the exponent of that variable is 2. So the domain is the set of all real numbers. Now, let's have another one here. So the difference from the previous example is that this is negative. Okay, so let's find f of negative 2, f of negative 1, f of 0, f of 1, f of 2. So here, you notice there is a negative sign here, and then the value of x is negative 2. So negative, and then negative 2 squared. It's better to put parentheses so you know that negative here for 2 is included in squaring. So this is negative 2 squared, that is 4, but there is a negative outside, so it means negative 4 minus 3. And that is equal to negative 7. If you have negative 1, so here, negative 1 squared is 1. So negative 1 minus 3, that is negative 4. f of 0, so that is equal to negative 3. And f of 1, so here 1 squared, that is 1, but there is minus sign or negative here, so negative 1 minus 3, that is negative 4. And the last one is f of 2 only. F of 2 is equal to minus or negative, then 2 squared, that is 4. So negative 4 minus 3, that is negative 7. So now we're going to plot the points. So that is the negative 2, negative 7, negative 2, negative 7. Next is negative 1, negative 4. So negative 1, negative 4. 0 is x, negative 3 is y. And then we have negative 1, positive 1 is x, and negative 4 is y. So it should be there. And then positive 2 is x, then negative 7. Okay, so now connect the points, and that's the graph, which is a parabola opens downward. A while ago, it's a parabola opens upward. Now, if we are going to look at the values of x here again, you notice this one means extended. So again, as we increase the values of x here, the graph will stretch to the right. And if we are going to decrease the value of x, means going to the left, and the graph also will stretch going to the left, which means it covers again all these values of x, which means that the domain again in this kind is the set of all real numbers. And the range, look at this one. The value of y, the highest is negative 3 and going down. Okay, so the y now, the range is the set of all y such that y is less than or equal to negative 3. So negative 3, less than or equal to negative 3. That's how you're going to write in set builder notation. But if you're going to write in interval notation, you can write from negative infinity, that is parenthesis, comma, negative 3, and then bracket. It means that 3 or negative 3 is included. That's why it's bracket. Now, we have another example here. Given f of x is equal to x plus 4. So this one is easy to manipulate. Simply, if x is negative 2, so f of negative 2 is equal to negative 2 plus 4, that is 2. I am not going to show anymore all of this. I know that you can substitute this. What we want now is to show the graph. So you can just plot the points, negative 2, 2. The first point, negative 2, 2. The next is negative 1, 3. Negative 1 is x, 3 is y. And then 0, 4, 0, 4. And then 1, 5, 1, 5. And then 2 for x, 6 for y. Okay, connect the points, and that's the graph, a straight line. And this is now a linear function. Now, look at the graph. If we're going to increase the value of x, or as x increases here, the values of y also increases. As x decreases, y also decreases, which means it covers all real numbers. So the domain now is the set of all real numbers. And the range also is the set of all real numbers. So now, if it is a linear function, how do you know that it's a linear function? It's one variable, and the exponent of x is 1. Means that the domain and range, the domain is the set of all real numbers, same as the range. Or you can write in interval notation again from negative infinity up to positive infinity, then parentheses. Same here. Next, how about this graph? Find the domain and range of the graph. So what are you going to do here is, this is -3 for x and y is 1. This one is 2 for x and 5 for y. Now, to find the domain, you look at this one. So the graph starts here. You just need to look at the two endpoints of the graph. But this is open circle, which means that -3 is not included. This is the x. So the domain here, parenthesis -3, because that's the x value. And since this is open circle, that's why we use parenthesis, comma, then 2, the other x at the other end, that is 2. And this is solid, therefore, this is bracket. That's the domain. The range, using interval notation, the value of y. So it starts here, 1. So that's 1. It's parenthesis because 1 is not included. And at the end point, we have 5. And 5, and that is bracket. Okay, so that's the domain and range in interval notation. It's easy to write in interval notation. Another graph here. So here, this is the point, the start here, the lowest point. And the coordinate of this point is -3 for x. Sorry. And then -3 also for y. And the other end, we have 5 for x. This is 5. And that is also 5 for y. Okay? So now, to find the domain, since this is solid, this one also, or shaded, which means that -3 is included. And 5 is also included there. So it means bracket, -3, comma, +5, another bracket. That's the domain. And the range, we have -3, that is for here, included, comma, +5, that is also included for the y. Last one. I have here two graphs in one Cartesian plane. There is a gap in here, which means to find the domain and range, we're just going to combine the set of domain here and this one, same as the range. So check here. This one, this first point is -3 and then -1. Here we have 1 and 2. Okay? Here we have 2 for x and 4 for y. And then here we have 4 for x and y is 7. So we can easily find the values of x. So the domain in the first one, we have here -3. So that's open circle, which means parenthesis, -3. Up to here, that is 1. And then bracket because this is solid. Then, since we're going to combine, we need to use the union. Okay? Union means another set, we're going to combine these two. So in the second one, we have 2 here, which is open circle. So that is parenthesis 2 up to 4, which is we need to use bracket because 4 is included. It's solid. For the range, here, -1. So open, or I mean parenthesis, -1 because this is open circle. And then here, solid, so 2. That's the value of y, so that is bracket. Union, that is start with 4, and that is open, or I mean open parenthesis, up to 7. And 7 is included because this is solid, so bracket. So that's how you're going to find the dominant range of the graph. That's all for this video, and thank you for watching. See you in the next one.